So 3/6 is compound inequalities. Okay, so we've been working with inequalities where your final answer comes out to x is less than 11 or x is greater than or equal to 16. Compound inequalities is just basically saying we have two different inequalities that are either joined by the word and or the word or. Okay, so and or type of situations. And let me tell you how this goes. In an and situation, I'm saying I want this to be true and I want this to be true. So it's going to be two different inequalities, but I want them both to be true. This and that. Like, who's going tonight? Brooke and Sarah are going. Okay, I want them both there, Brooke and Sarah. Whereas if I said, who's going tonight? And I said, oh, it'll be Brooke or Sarah. That means one or the other, not both have to be in attendance, okay? So here's basically how I think of it. When it is an and problem, you are looking for the overlap of your two inequalities. So take a look at this one. If I said x is greater than or equal to 3 and x is less than or equal to 7, both of those things have to be true. So x has to be greater than or equal to 3. That's the red. X has to be less than or equal to 7. That's the blue. I'm looking for where do those two graphs overlap each other? And the overlap is this green graph down below here. Okay, so when it's an and problem, think overlap. Where do they meet? Where do they intersect? Where do they overlap? Okay. When it is an or problem, I always say think of it like the oars in a boat. The oars in a boat actually go out of the boat, right? They go this way. So while you're sitting in the boat, those oars aren't going to necessarily touch each other. They're not meeting in the middle. They're going away from each other outside of the boat. That's an or problem. And with an or problem, we're saying this can be true or this can be true. So for instance, if I say x is less than -2, or x is greater than or equal to 1. That means your solution is not any of the points in between here, okay? But it is either the stuff to the left or the stuff to the right. So x can be less than -2, which would be graphed like this. X is greater than or equal to 1, which would be graphed like that. So my answer, my actual graph, is the green that you see there. Does that make sense? And versus or. And is where do they overlap? Or will not have overlap, so all of it is true. Okay? Okay. So it says write a compound inequality. What inequality represents the phrase? And then graph that solution. So this says all numbers that are greater than -2 and less than 6. Okay, so x is going to be greater than -2 and x is going to be less than 6. Now, here's the beautiful thing about and problems. Because it's everything that falls in between, it's the overlap of them, you can actually write these if you want as one big inequality setup. The way you do that is if I flip this first guy around, okay, if I call this -2 is less than x instead, then I can just keep that x as my x in the middle and say x is also less than 6. So this is actually the same thing as this, and it just looks a little bit nicer. It's up to you if you want to write it that way or not. Basically, we're saying x is going to fall between -2 and 6. Okay, if you like to write them separately with the word and, that's fine too. Okay, so let's think about how we would graph this. If x is greater than -2, is that an open or a closed dot at -2? Open. That is an open dot at -2. What direction would our arrow go? Right. To the right. Okay, so it's an open dot going to the right at -2. Then it says x is less than 6. Is that open or closed dot? Open. That's open. And if we were to shade that in, it would go to the left. Now, technically, this arrow keeps going this way and this arrow keeps going this way, but we are looking for where do those two graphs overlap? They meet in the middle, right? So your answer is 2 open dots with this bar in the middle shaded in. Okay, so I don't want to see this. That stuff up top, it might help you to figure out what your graph is, but I don't want to see all of that stuff. I want to see what is your graph. The graph for this situation where it is an and problem is everything between -2 and 6. Okay, so you do open dot, shade in between. Okay, look at letter B. All real numbers that are less than 0 or, okay, so here's your big or, greater than or equal to 5. See if you can write those two inequalities. All real numbers that are less than 0 would be 1. And then the other one, all real numbers that are greater than or equal to 5. No, that's a great question. The or questions you cannot write as one big one because it's not inclusive. It's not like the overlap of the two. They're two totally separate things and we want either one of them to be true. It's a great question. Okay, so how did you write this one? X is, where is your inequality opening to? The number or the variable? It's less than 0.
The variable?
It's going to point to the variable. It's going to open to the number, right? X is less than 0. So yours look like that. Okay. Or greater than or equal to 5. So greater than or equal to 5 would look like that. Like Khalees just asked, because this is an or problem, you can't say 0 is, like, you don't want to write it this way. Okay, that doesn't make sense with this symbol like that, so don't set it up that way. You have to keep it an or problems, two totally separate things. So X is less than 0. Is that open or closed? Open. And what way does your arrow go? To the left. X is less than 0. Or your X can be greater than or equal to 5. Is that open or closed? That's closed because it has the equal to bar, and then you're 5. So it would look like that. Okay, so all of your answers, in other words, I could pick -3. -3 would be a solution. Okay, is 3 a solution to this inequality? No, 3 is not, right? This is not shaded in, doesn't have a point on it, doesn't have a line on it. That's not a solution. Is 8 a solution to this compound inequality? Yes, it is, right? This right here would be a solution. Okay, so sometimes you're gonna have to solve compound inequalities that have and or with them. The and ones, I think, are the easiest in terms of you can do the same thing over and over and over again. But some people forget to do it to everything. So let me just show you this setup. Okay, this is a compound inequality. This is an and type of situation. They made it one big setup. Okay, so the m-4 in the middle, the -3 by itself, the -1 by itself. We want to isolate the variable. Can anyone tell me how we can get m by itself right now? Khalees. Yes, you're going to add 4, okay? So kind of think of it like this. It's 3 separate things here. You have the middle, the left, and the right. If I'm going to add 4 in the middle, I have to add 4 everywhere. So that means I have to go +4 here, and I have to go +4 here. Okay, so it's almost like if you wanted to, you could set it up as 2 totally separate inequalities and solve them both. It's way more work, and I don't recommend it. Just do whatever you do in the middle to everything else. So -3 + 4 is 1. Your symbol's going to stay the same. -1 + 4 is 3. So 1 is less than or equal to m, which is less than 3. That means my answer is going to have what two numbers as points?
1 and 3.
1 and 3. Is it going to be open or closed at 1? Closed because of this bar, right? So it's a closed dot at 1. Open or closed at 3? Open at 3. And then do I shade in between or do I shade away from each other? In between. It's everything that falls between 1 and 3, okay? So you shade this in. We want the overlap of the two, and you're done. Does that make sense? Okay. So here's an example. It says to earn a B in your algebra course, you must achieve a test average between 84 and 86 inclusive. That means including 84 and including 86, okay? This is not true for our school, by the way. Ours would be 83 to 86. And that doesn't necessarily hold true for your test averages. You scored 86, 85, and 80 on the first 3 tests. What possible scores can you earn on the 4th test to earn a B in the course? Okay, so here's what they're saying. You want to get between 84 and 86. Okay, so our extremes are the 84 and the 86. You want to fall somewhere in between there. Now, if we're including 84 and 86 and we put symbols in between there, is there going to be an equal to bar or is it going to be just a less than? Equal to. Okay, so we're going to go like this. It's going to be between 84 and 86, including the 84 and the 86. Now, what they're saying is you have to get an average score between those numbers. Do you know how to find an average?
You add everything and then divide by the amount.
That was like perfectly in sync. You add up all the numbers and you divide by how many numbers there are. So they're saying on the first 3 tests, you scored 86, 85, and 80, but they want to know what your 4th test needs to be. So your 4th test is going to be what right now? It might be. We don't know what it is. What do we call something we don't know in math? X. Give it a variable, okay? Here's what we're going to do. We're going to say 86 plus 85 plus 80 plus whatever you get on that 4th test divided by what? 4. There are 4 tests. We're finding the average of 4 tests. Okay, so it looks like this. We want to solve for what X is. So here's what we're going to do. First thing I'm going to do is I'm going to simplify all of this. So 86 plus 85 plus 80 is 251. So 84 is less than or equal to 251 plus X divided by 4, which is less than or equal to 86. Okay, now forget about the fact that you have inequalities going on right now. I want to isolate X. I want to get X by itself. So if we just look at the middle chunk, what would you have to do to get X by itself first? You multiply. You are dividing right now. We're dividing by 4. So to get that 4 out of there, you'd have to multiply by 4, right? That's going to get the 4 out of there. But the rule is, whatever you do to one side, you have to do to the other, and in this case, to both other sides, right? So if I multiplied by 4, then I need to multiply by 4 everywhere. And that becomes 84 times 4 is 336, is less than or equal to 251 plus X, which is less than or equal to 344. Everyone with me on that? So I just got rid of the 4 by multiplying. I still want to isolate X. How do I get X by itself in the middle? Subtract. So if I'm going to subtract 251 here, then I have to subtract 251 here, and I have to subtract 251 here. So that's the biggest difference on these, is instead of just doing it to two sides of an inequality, now you're doing it to three different places, okay? Whatever you do in the middle, you have to do to both sides. So when you do that, you end up with 85 is less than or equal to x, which is less than or equal to 93. Can anyone tell me what this means? On what? On the fourth test, right? If you get between an 85 and a 93 inclusive, so could be an 85, could be a 93. If you get that grade on the last test, then you will get a B in the class. Does that make sense? Beautiful. Okay, then solving compound inequations, inequalities, inequations. That's an interesting phrase. Solving compound inequalities with the word or, okay, is a little bit different because now it's two separate inequalities, right? The last time when it was and, we did it as one big inequality and we just did whatever you do to the middle, you do to the sides. These are totally separate. So these might feel easier to you because you just solve them totally separately and you already know how to solve these. So when you have an inequality, a compound inequality, and they are or problems, look at one and then look at the other. So starting with 3t plus 2 is less than negative 7. How do I solve this inequality?
Minus 2.
Take away 2. So you get 3t is less than negative 9. Then what? Divide by 3. Do I flip my symbol right now? Negative 9 divided by 3? No, because you divided by a positive, okay? Even though the other one was negative, doesn't change it. Okay, so here's part of it. T is less than negative 3. Or, now go to the other side. How do you solve this inequality? Subtract 5. So negative 4t is less than negative 4. What's your next step? Divide by what? Negative 4. Do I flip? Yes, this one you have to flip because you divided by a negative. So t is greater than, what's negative 4 divided by negative 4? 1. Positive 1. Okay, so this one should feel very familiar to you because you know how to solve both of those already. It's just how you graph it now. What do you do at a negative 3? You're going to go to the left, open or closed? Open. This is going to be open, right? There's no bar. So open dot at negative 3, and you go left because it's less than the negative 3. Open or closed at 1? Open at 1, and you go what direction? Right. To the right. Okay, so the fact that it's an or problem should tell you like, hey, my graph should be looking like this, right? Oars, like the oars in a boat, they go out to the side. This is how it should be. Questions on that at all? Okay, I was talking to Mrs. Graham and we both decided this is not necessarily, we don't even get into interval notation in Algebra 2 yet. If you get to advanced math and calculus, you'll do some interval notation, but we're not even going to do it. It can be a little tricky, and we don't think it's necessary for what you guys are going to be doing in this class. So you can just skip that part, put a big scratch through it so that you don't try to go back and turn it in with the notes or anything. Any questions on any of that?